So today is the first day of Honors Algebra 2, Unit 2 on quadratics, but we're going to start with some Algebra 1 review because the process of factoring, which is what we're going to cover today, is one of the most used over and over and over procedures for the rest of your math career. So we're going to take today and actually the next class to review the process of factoring. On page 1, it's completely blank. I want you to pause the video and write down what you see in the box. So quadratics in standard form, quadratics are polynomials that have the highest power is 2. So x squared makes an equation a quadratic. In standard form, we have a number x squared, so a stands for any number, ax squared plus bx plus c. Factor as a noun, as an object, is something that divides evenly. Factor as a verb is to write the polynomial as a multiplication problem. So we are going to be factoring as a verb, rewriting polynomials as multiplication problems. There are 4 methods. We're going to do 3 today. So continuing on page 1, write down 4 ways to factor a quadratic. Number 1 is greatest common factor, GCF for short. And greatest common factor, we think, what divides evenly amongst all the terms? So we have 6x squared and 18x. 6 and 18 both divide evenly by 6. And x squared and x both divide by x. But this is just our thoughts. This is our work. It's not 6x divides away. Remember, we're rewriting as a multiplication problem. So if I factor out 6x, what remains is x minus 3. I've now rewritten the quadratic as a multiplication problem. If I distributed the 6x back, I'd get the typed answer. All right, so let's try another one. Let's do 9x cubed minus 3x squared. Pause the video here and factor out the greatest common factor. All right, so you should be thinking divide evenly by 3. Divides evenly by x squared. And what remains is 3x minus 1. All right, let's try one more. Let's do 2x squared plus 4x plus 6. Pause the video and rewrite 2x squared plus 4x plus 6 as a multiplication problem, factor. Since not every term has an x, the only greatest common factor will be a number. And I notice 2, 4, and 6 are all even numbers, so I can factor out the 2. And we're left with 2 times that quadratic. All right, method 2 is difference of 2 perfect squares. If you have a number squared minus a number squared, it has to be subtraction. That can factor to a plus b, a minus b. These are called conjugates. It's the same term, same binomial, opposite signs. So we have x squared minus 9. Is x squared a perfect square? Yes. Is 9 a perfect square? Anything times itself 9? Yes, 3. So this is going to factor to x plus 3, x minus 3. If I multiply these back together, we should get x squared minus 9. Let's try it. X times x times negative 3, 3 times x, 3 times negative 3, And the -3, +3, these x terms, they add to 0, and we are left with x squared minus 9. It worked. We rewrote it correctly as a multiplication problem. All right, let's try another one. I want you to try, let's do x squared minus 49. What does that factor to? You should say x plus 7, x minus 7. If you wrote x minus 7, x plus 7, that's absolutely fine. It's the same two terms multiplied, just in a different order. All right, let's try 16x squared minus 1. That would factor to 4x plus 1, 4x minus 1. Because 16 is 4 times 4, x squared is x times x, it is subtraction, it has to be subtraction, and 1 is 1 times 1. All right, one more. Let's do 12x squared minus 75. Wait a minute. What times itself is 12? Nothing. So is there a greatest common factor that we can divide out of both of these? I know 12 divides by 3. Oh, 75 divides by 3 as well. So let's factor out the 3. And we're left with 4x squared minus 25. Now do we have a difference of perfect squares? We do, so let's factor one more time. That's going to be 2x plus 5 and 2x minus 5. So there's three factors that multiply back to 12x squared minus 75. 3 times 2x plus 5 times 2x minus 5. All right, our last method for today is a trinomial. That means 3 terms where A being this number in the front, leading coefficient, where A is 1. And the method for that is to find 2 numbers that multiply to C and add to B. So if we write the standard form down here so you can see it in my video, when this number is a 1, our process is what multiplies to the C, the constant, and adds to the B. All right, so our first example is x squared minus 5x plus 6. What multiplies to 6 that adds to negative 5? You don't have to do this in your head. You can list out all the multiples of 6. That's 1 times 6 and 2 times 3. But to add to a negative, but multiply to a positive, both numbers have to be negative. So negative 1, negative 6 multiplies to positive 6. Negative 2, negative 3 multiplies to positive 6. But negative 2, negative 3 adds to negative 5. So this factors to x minus 2, x minus 3. If we multiply this back together, x, and distribute every term together, it would equal this quadratic. All right, let's try x squared plus 5x minus 24. Oh, sorry. X squared plus 5x minus 24. What multiplies to negative 24 and adds to 5? So 24, we get 1 and 24, 2 and 12, 3 and 8. And to multiply to a negative, one of the numbers must be negative, and we want to add to a positive. So if we're adding to a positive, that means the smaller numbers are the negatives. So 24 minus 1 is not 5. 12 minus 2 is not 5. But 8 minus 3, that's 5. So this factors to x minus 3, x plus 8. All right, right, let's do one more. Let's do x squared minus 2x minus 15. So all the ways to multiply to 15 are 1 and 15, 3 and 5. But to multiply to a negative, one number has to be negative. And to add to a negative, the bigger value is the negative. And 3 minus 5 is the negative 2. So we've got x plus 3, x minus 5. We will do method 4 tomorrow, or the next class, when the leading coefficient a is not 1. On page 2, we're going to draw a flow chart of what our thought process is for every factoring problem. Every single problem, you're going to look, is there a greatest common factor? If there is, you're going to factor it out. Then we analyze our equation further, and is it a binomial, which is 2 terms, or trinomial, which is 3 terms. If it's a binomial, one method we talked about today was difference of perfect squares. We will add other binomial factoring later through the unit. This is just the Algebra 1 review. We will do new methods of factoring in Algebra 2 later. Trinomial, what we did today, was when a equals 1, that was multiply to c and add to b. Tomorrow, or the next class, we're going to do when a is not 1, method to be determined. So this is our flow chart, every factoring. Is there a greatest common factor? If there is, factor it out. If not, then we decide 2 terms or 3, and then that leads us to the method that we would use. So I want you to pause the video here after you hear my directions. On page 2, so you've got your flow chart written somewhere now. Tomorrow, or the next class, we're going to do 4, 7, and 8. So just skip those for now. Don't totally cross them out. We're going to do them the next time. I want you to pause the video and see if you can factor every other problem before you check your solutions. All right, and number 1, is there a greatest common factor? No, all of these cannot divide by something. Is it 2 terms or 3? It's 3, so I'm gonna say what multiplies to negative 18 that adds to negative 7 will be negative 9 and positive 2. So that factors to x minus 9, x plus 2. Number 2, is there a greatest common factor? No, it's a binomial. Is it subtraction of 2 perfect squares? It is. So that goes to conjugates, 2x plus 1, 2x minus 1. Number 3, is there a greatest common factor? Yes, 16 and 4 can both divide by 4. Now I'm left with a binomial. Is it a subtraction? No, so that does not factor further. That's done. 5, is there a greatest common factor? No. 3 terms, trinomial. What multiplies to 9 that adds to negative 10 will be negative 1, negative 9. So x minus 1, x minus 9. Greatest common factor? No. Trinomial. What multiplies to 42, negative 42, but adds to 1? It's going to be positive 7 and negative 6. 7 and 8, those are tomorrow. All right, 9. Greatest common factor? Yes. We can factor out a 3. I'm left with a binomial. Is it difference? It is subtraction. Is it perfect squares? It is. We can factor more. What times itself is 4? is 2. I need a positive and a negative. Those conjugates, same binomials, opposite signs. Okay, so now your independent practice is page 3, just 1 through 6, 16 to 18, and 21. Check your answers with the key posted in Drive, and come see me if you have questions before school or at lunch the next day if you get stuck.